Figure 2.7 daily percentage change in the euro Swiss franc exchange rate. Vertical axis percentage change ranging from -20 to 5 up towards 5. And the years on the horizontal axis 2014, 2015, 2016. The day-on-day percentage change in the value of the euro and Swiss francs for a year before and a year after the unpegging of the Swiss franc on January 15, 2015. So was the probability of a fall at least this large really so small? Restarting that sentence. So was the probability of a fall at least this large really so small? Well, no. The error here is to not investigate the nature of our data further and to fail to understand the actual process that determined the value of the currency. The Swiss franc had in fact been kept within very small bonds due to the actions of the country's central bank in setting a so-called peg for the currency. In the previous 12 months, this had been within the range of 1.2008 and 1.236 Swiss francs per euro. In fact, the introduction of this peg over 3 years earlier had caused an appreciation of the euro against the Swiss franc over 20 standard deviations, again assuming a normal distribution derived from previous daily changes. Superscript 2, which reads, see the article published in Reuters, Charts of the DAT Swiss franc edition by Felix Salmon, September 6, 2011. Returning to the text, it was the introduction of the peg that had caused such little volatility in or such a low standard deviation of the value of the currency. Once this peg was removed, as happened on that particular Thursday, the value of the currency was able to float and vary according to market factors. Investors responded to the removal of the peg by bidding down the value of the euro against the franc substantially. It is not only the removal of a currency peg in this way that can cause extreme fluctuations. The result of the 2016 Brexit referendum in the United Kingdom, an event that, while seen as unlikely, was at least partly foreseeable, led to an appreciation in the value of the euro against British pound sterling on June 24, 2016 of 6.17%. This is equivalent to 9.8 standard deviations based on data from the previous year, or an event with an apparent probability of 5.629 times 10 to the negative 23. While it may seem substantially more likely to occur, the probability of such an event actually taking place is less than once every 1 and a lot of zeros, 18 zeros years. I believe that's 1 quintillion years. Again, it seems unlikely that this is an accurate characterization of the probability of such an event occurring. Clearly, it is dangerous to assume that data is normally distributed or that recent observations of a variable will provide a useful prediction of the range of future values. Indeed, it is partly for this reason that advertisements for financial products in the United Kingdom must carry a disclaimer that past performance is not a guide to future performance. There's a superscript 3. This is based on the assumption of 260 trading days per year.